The Sun, our mighty solar king, is a place of extreme energy and harsh conditions. Even so, it stands out as our greatest source of light and heat. Every body in the solar system is tied to its fate, since as the Sun goes through changes, everything around it adapts as well. While this star continuously fuses elements in its core, the planets are born and shaped according to its will, and the closer you are to it, the more violent the consequences. Some places suffer immensely from solar radiation, while others get just enough to host completely different phenomena. In this context, there is a special zone where solar energy arrives just right to sustain life: Earth. Even though our planet has a magnetic shield capable of deflecting charged particles, the Sun constantly tries to sweep away the Earth's atmosphere with its solar wind. Yet, Earth remains steadfast and is an amazing home, even if it isn't the only fascinating place out there. To start our journey, let's head straight to the largest planet in the solar system, Jupiter, the gas giant that acts like a real protector for the rest of the system. If you, like me, are passionate about the cosmos, subscribe to the channel and turn on notifications so you don't miss any of our journeys through the universe. Jupiter is a world as impressive as it is dangerous. Even with many studies on its atmospheric layers, filled with colorful clouds and violent storms, a large part of its interior remains a mystery to science. The big question revolves around what is hidden in its core, something that has puzzled researchers for decades. However, thanks to data from a specific probe mission, this secret is slowly being unveiled. To get an idea of Jupiter's colossal size, just know that its diameter is about 139,000 kilometers. If Earth were compared to a simple grape, Jupiter would be equivalent to a basketball. Basically composed of hydrogen and helium, the gas giant resembles, in many ways, an incomplete star. In its turbulent atmosphere, gigantic hurricanes can be larger than our own planet, accompanied by high-speed winds and lightning up to 100 times stronger than those on Earth. But what really grabs attention lies deeper, far below the cloud layer we see. Deep inside Jupiter, hydrogen gas becomes hotter and denser as you approach the core. Thousands of kilometers beneath the clouds, the pressure reaches such incredible levels that it turns hydrogen into a kind of liquid metal. This exotic fluid is electrically charged, hence the name liquid metallic hydrogen, and spans roughly 80% of the planet's total volume, forming what can be described as the largest ocean in the entire solar system, although it isn't actually water. It is this layer that generates electrical currents responsible for Jupiter's extremely strong magnetic field, about 20,000 times stronger than Earth's. In laboratories, scientists have briefly produced this metallic hydrogen state, but only in very small amounts and for short periods, because colossal pressures are needed to maintain it. Yet all this fluid vastness still doesn't bring us to the true core of the planet. Although the liquid metallic hydrogen surrounds what we call Jupiter's heart, the big question remains: what is the nature of that core? Initially, it was believed that it was composed of heavy materials like iron, nickel, and various types of ice, all compacted into a rocky structure. This conclusion was partly based on the analysis of Jupiter's intense gravitational field, which suggested a massive center. However, modern observations have led scientists to rethink that view. Thanks to data collected by the Juno probe, it was discovered that Jupiter's interior is diffuse. This means there isn't a well-defined boundary separating the core from the rest of the planet. Pieces of solid material seem to be scattered among the layers of hydrogen, resulting in a central area that stretches over much of Jupiter's interior. This unexpected discovery raised the possibility that, at some point in the past, a catastrophic collision occurred with another massive planetary body, perhaps a protoplanet or even a small gas planet in formation. The impact could have been so violent that it destabilized and dispersed Jupiter's core, mixing heavy elements with hydrogen in very deep regions. Orbital dynamics studies and even the small size of Mars point out that collisions of this scale were relatively common during the early stages of the solar system. The Juno spacecraft, which orbits Jupiter, uses gravitational measurements to peer through the planet's thick layers. By analyzing tiny variations in its gravitational field, the probe can deduce the gas giant's density and composition. This technique gradually reveals Jupiter's complex internal architecture, confirming the presence of an intriguing and possibly diluted core. More data will be collected over time, in the hope of better understanding how this planet formed, why it became so gigantic, and, above all, what really resides in its mysterious heart. Juno's microwave radiometer can detect the thermal radiation emitted by the deepest regions of Jupiter's atmosphere, providing clues about what lies beneath those impressive swirling clouds. Still, all this data is collected from space, without an actual dive into the gas giant's interior. The big question is, will it ever be possible to send a probe capable of plunging into Jupiter's atmosphere? Launching equipment into the depths of Jupiter's clouds is a task full of challenges. The planet's environment is extremely inhospitable, with intense radiation, extremely high temperatures, and pressures capable of crushing almost any device daring enough to go too deep. As ambitious as it is, this idea was once put into practice. In December 1995, NASA's Galileo spacecraft launched the Galileo Atmospheric Probe, which entered Jupiter's atmosphere with several instruments. During its descent, the probe measured temperature, pressure, and gas composition, and even detected lightning on another planet for the first time. However, as expected, the probe didn't last long. After 58 minutes of data collection, it was destroyed by the hostile environment it was investigating. Meanwhile, Juno continues its exploration from the outside in. It ventures through Jupiter's radiation belts and uses its entire scientific apparatus to unravel details about Jupiter's structure and dynamics. There are still plenty of mysteries, especially when talking about that vast ocean of liquid metallic hydrogen and Jupiter's diffuse core. Every new discovery reinforces the fascination that the gas giant holds over us, offering clues not only about the planet itself, but also about the formation history of the solar system and even other planetary systems scattered throughout the universe. But the greatness of our cosmic neighborhood isn't limited to Jupiter. The solar system hosts an impressive cast of worlds and satellites, many of which are as enigmatic as Jupiter itself. There are moons that boast breathtaking phenomena such as Io, bursting with active volcanoes, or Titan, which displays rivers and lakes, though made of methane and ethane instead of water. Then there's Europa and Enceladus, whose subsurface oceans fuel the hope of finding life beyond Earth. It's an astonishing variety of landscapes that stretch all the way to the edge of the solar system. It is by venturing to the outskirts of our system that we encounter Neptune's largest moon, Triton. This unusual, icy sphere stands out for a surprisingly intriguing origin story, possibly very far from Neptune. Scientists believe that Triton didn't form around the blue giant at all, but was rather captured by it, beginning an eternal link, one that will probably end dramatically. Today, we have a reasonably solid understanding of how most of the solar system's moons developed. In rocky planets, for example, many satellites may have emerged after massive impacts, while around gas giants, it's likely that a disk of matter around the planet condensed, resulting in several moons. However, Triton does not follow this pattern. Voyager 2, which reached Neptune in 1989 after traveling 7 billion kilometers in 12 years, was the only spacecraft to visit the planet. Its observations revealed an intense blue atmosphere and colossal storms, like the Great Dark Spot. And if that wasn't enough, the probe also flew by Triton, capturing images that showed craters, nitrogen caps, and cryovolcanoes ejecting frozen material kilometers into the air, all in one of the coldest places in the solar system. Voyager 2's flyby of Triton was quick and limited by the technological capabilities of a probe launched in the 1970s. Even so, the data obtained led to the conclusion that Triton's orbit, tilted by 157 degrees and moving in the opposite direction of Neptune's rotation, completely differed from the characteristics of the regular, larger moons of the solar system. In addition, the density profile, color, and composition are much more similar to typical Kuiper Belt objects like Pluto or Eris. This evidence raised the hypothesis that Triton might actually be an ancient dwarf planet captured by Neptune's gravity. If this theory is correct, then the encounter between Neptune and Triton wasn't exactly friendly. The huge moon would have destabilized Neptune's original satellites, leaving only a few inner orbits intact. Moreover, Triton continues on a retrograde path that slowly pulls it closer to Neptune. In about 3.6 billion years, it should cross the Roche limit, where tidal forces will rip the satellite into countless fragments that will form a spectacular ring around the blue giant. A dramatic and yet fascinating phenomenon. The last visit to Triton by Voyager 2 took place over 3 decades ago. Since then, new missions have been proposed, such as NASA's Trident, designed for October this year, with the aim of conducting another close flyby and a detailed study. The plan was to use gravitational assists from several planets to reach Neptune and then study Triton's cryogenic jets, its possible internal ocean, and map its surface better. Unfortunately, the mission was canceled in favor of projects focusing on Venus. Although studying Venus is also of great scientific value, we lost another chance to deeply investigate this mysterious moon. One of the great ironies in this story is that, despite Triton seemingly having a tragic end in store, Neptune might sport majestic rings as a result of this process, much like Saturn. And it doesn't stop there. The solar system houses an almost unimaginable number of celestial bodies, from tiny meteorites to impressive gas giants. Saturn, for example, boasts its own family of dozens of satellites, each with unique characteristics and intriguing paths. Yet, the combination of phenomena surrounding Triton's fate stands out by uniting history, mystery, and a truly impactful future. Saturn isn't remarkable just because of its size. Its famous rings have possibly made it the most iconic planet in the solar system, apart from Earth. However, it wasn't always obvious to humanity that such an impressive structure surrounded this gas giant. More than 400 years ago, at the beginning of the 17th century, the available technological resources for observing the sky were limited, and modern astronomy was in its infancy. It was Galileo Galilei who kickstarted countless astronomical discoveries by pointing his rudimentary telescope at the heavens. In a short time, Galileo identified craters on the Moon, phases on Venus, and even sunspots, and he discovered Jupiter's moons, which helped prove that Earth was not the center of the universe. However, when he turned his telescope toward Saturn, he encountered something so peculiar that he couldn't figure out what it was. The telescopes back then had much poorer quality lenses compared to today, which made it even harder to understand the anomaly around that distant planet. In his early observations, around 1610, Galileo thought that Saturn was actually a set of 3 bodies, one larger one in the middle and 2 smaller satellites on the sides. By 1612, when he looked again, he noticed that those supposed companions of Saturn had simply disappeared. In 1613, the structure reappeared, causing even more confusion. Today, we know that this disappearance was due to the tilt of the ring system. At that time, they were aligned with Earth, becoming invisible because they were extremely thin. Unfortunately, Galileo died before he could fully understand what those appendages around the planet were. It wasn't until about half a century later that people began to suspect that Saturn actually had a ring system. One of the main theories on how this impressive structure formed suggests that around 100 million years ago, a large icy moon came too close to Saturn. The gas giant's devastating tidal forces shattered it into countless fragments, which spread out to form a main ring around the planet. Over millions of years, part of this debris was swallowed by Saturn. Some hit neighboring moons, and others might still be wandering the solar system today. Although this is the most accepted hypothesis for the ring's origin, they still hold secrets that science strives to uncover. Saturn's rings do not have a clearly defined boundary. Their most visible portion extends about 280,000 kilometers in width, although sparse dust and gas particles can reach up to 16 million kilometers in diameter. Huge, but very low in density. Despite the colossal size, the total mass of this ring isn't very large compared to other celestial bodies. It's estimated to be about 2,000 times lighter than our Moon. Only 3% of this entire volume is made up of solid matter like ice chunks. The rest is composed of gas and dust. In a powerful telescope, you can also see that the larger rings are made up of several smaller rings, separated by gaps caused by the gravitational influence of both the planet and its moons. The innermost part of Saturn's complex ring system, the D ring, is about 16,500 kilometers above the planet's upper atmosphere, mostly made of ice crystals and frozen methane. Right after, you find the C ring, denser and with objects up to 2 meters in diameter. Next comes the B ring, the brightest, only a few meters thick for the most part, but capable of forming walls up to 2.5 kilometers high on the edges. Further out is the A ring, about 14,600 kilometers wide, where chunks of 10 meters or more appear, even with some miniature moons like Pan and Daphnis. Saturn also has more external rings, such as the F, G, and E rings, which are basically made of dust and rarefied gas. The E ring, for example, is associated with the moon Enceladus, which ejects jets of water vapor and ice through its cryovolcanic activity. Enceladus, with only about 500 kilometers in diameter, hides an ocean of liquid water beneath a crust of ice roughly 2 kilometers thick. Down below, the presence of salts and ammonia prevents the water from freezing completely, while internal heat exchanges help maintain the temperature. When these geysers pass through cracks in the surface, some of the material is lost into space, feeding the E-ring while also enriching the thin atmosphere of this small moon. Further out, there's Titan, Saturn's largest moon, with an impressive 5,152 kilometers in diameter, larger, in fact, than Mercury. Titan stands out for having a thick atmosphere, 1.5 times denser than Earth's, composed mostly of nitrogen with traces of methane. In this cold environment, with temperatures around -180 degrees Celsius, there are lakes and rivers of liquid methane and ethane, something unimaginable on our planet. Curiously, chemical processes high in the atmosphere transform the nitrogen and methane into more complex compounds that slowly settle on the surface. Titan's orbit, combined with its rotation and internal activity, helps replenish part of the gases in its atmosphere, offsetting natural losses to space. In the distant future, when the Sun evolves into a red giant phase, Titan's outer layers might warm up and become more favorable to life, even though this scenario is billions of years away. In a way, Saturn with its many moons forms a mini-system within our solar system, packed with variety and impressive phenomena. And it doesn't stop there. Jupiter also has its own set of dozens of satellites, each with unique characteristics. Among these, Europa stands out. Like Enceladus, it is believed to host a subsurface ocean beneath an icy shell, possibly gathering the basic ingredients for life as we know it. This icy world, Europa, shows a landscape full of intriguing fractures and streaks, along with dark spots popularly called freckles. These formations have piqued scientist curiosity for years. In terms of exploration, up to now 6 spacecraft have flown by it, with the Galileo probe contributing the most, with about 12 flybys dedicated to the moon. The images and measurements pointed to a young surface, few craters, and structures suggesting constant renewal, possibly caused by the internal forces of a vast ocean or geological processes similar to those on Earth. The hypothesis of a subglacial environment with liquid water makes Europa one of the most promising places in the search for life beyond Earth. What's fascinating is that even after centuries of observations and missions, Saturn, Jupiter, and their moons continue to hold mysteries that lead us to ask new questions and create fresh theories. And given the vastness of the universe, it's likely that there are countless other planetary systems just as, or even more, complex, waiting to be unraveled. Each space mission we send offers us a deeper glimpse into phenomena that once seemed like pure fiction, bringing us a bit closer to understanding this cosmic orchestra full of surprises. The visible marks in this image are about 10 kilometers in diameter, and both their size and shape suggest that warmer ice is moving beneath colder ice in Europa's outer crust, much like what happens with magma chambers in Earth's crust. The smooth, dark areas may have formed when the warmer ice burst onto the surface, while other formations could be cracked blocks of crust trapped in a layer of dark ice just below, like huge icebergs in a frozen sea. Upon closer inspection, the tops of the structures resemble the surrounding ice, indicating they were pushed upward without completely breaking apart, unlike the darker spots. Recent research suggests these peculiar bulges might be sitting on lakes of liquid water that are completely encapsulated within the outer ice layer, as if they were pockets of water. It is believed that Europa's icy shell is about 25 kilometers thick and is made mostly of water ice as strong as granite. However, these lakes might not be the only hidden water reserves that Europa keeps secret. Scientific data indicate the existence of a global ocean beneath this solid layer. The vast fractures and linear cracks covering the moon follow a pattern that is still not well understood, but it could be the result of Jupiter's powerful gravitational pull along with that of its other Galilean moons. This constant tug and stretch is known as tidal flexing, and probably produces enough internal heat to keep large amounts of water in a liquid state. Furthermore, the cracks appear to be filled with some dark material, suggesting that some of it comes from inside the ocean, reaching the surface through these gaps. Additional evidence of the subsurface ocean comes from analyzing the patterns of some of Europa's longest lines. They do not match what would be expected if the crust were completely fixed, but they make total sense if the surface is able to slide independently, as would happen if a large ocean existed underneath. Measurements made by the Galileo probe also reinforce this theory. While flying by Europa, disturbances in Jupiter's magnetic field suggested the presence of a salty ocean generating its own electrical field. To complete the picture, observations from the Hubble Space Telescope recorded possible plumes of water vapor erupting from the surface, similar to the cryovolcanic eruptions seen on Enceladus, Saturn's icy moon. If confirmed, this would indicate that future missions could collect samples from the ocean without having to drill through the thick ice layer, as happened with Cassini at Enceladus. All of this places Europa as one of the most promising candidates in the search for life beyond Earth, since in an ocean floor heated by hydrothermal activity, generated by the tides and constant friction, conditions could be similar to the deep-sea vents on our own planet that may have been the cradle of life. It's no coincidence that 2 missions are on their way to investigate this fascinating world further. The first is NASA's Europa Clipper, which will perform dozens of flybys to determine whether Europa really has what it takes to support life. Launched in October 2024 on SpaceX's Falcon Heavy rocket, it won't reach Jupiter until the early 2030s, so we'll have to wait a few years to see the results, but it promises to be a milestone in space exploration. The second mission is the JUICE probe from the European Space Agency, which will also study Europa, as well as Ganymede and Callisto. It was launched in April 2023, but it is expected to reach the gas giant around 2031. At the beginning of the 2030s, we will have an exciting moment for astronomy and astrobiology as these 2 missions start to reveal new data about Jupiter's icy moon. Place your bets. Will we find life in Europa's oceans? And it's important to remember that space exploration is not new. Mars, for example, already has over 60 years of missions and discoveries that have gradually unveiled many of its secrets. It all began in 1964 with Mariner 4, the first probe to truly approach Mars. It arrived on July 14, 1965, taking 22 historical photos of the planet. At that time, the instruments detected a much thinner atmosphere than expected, and they didn't register a magnetic field or radiation belts. Even without signs of water or life on the surface, these discoveries paved the way for new questions and studies. Then came the Mariner 6 and 7 probes, launched in 1969, which also flew by the Red Planet, analyzing its atmospheric composition and capturing 201 images of different regions. Although they only covered 20% of the Martian surface, that was enough to excite scientists. Soon after, there were Mariner 8, which unfortunately failed, and Mariner 9, which reached Mars in 1971 during a colossal global dust storm. With patience, the dust settled, and the probe was able to transmit thousands of images, revealing enormous canyons, dry riverbeds, and gigantic volcanoes, including Olympus Mons, the largest volcano in the solar system. In 1975, NASA accomplished the first successful landing on Martian soil with the Viking 1 and 2 probes. These twin missions were a real leap forward, precisely mapping much of the planet and sending panoramic images of the reddish landscape. Even though the life detection experiments didn't find any organisms, this initiative paved the way for decades of exploration that would continue to surprise us. However, after the Viking program, it took more than 2 decades for NASA to resume plans to get close to Mars. It wasn't until 1996, with the launch of Mars Global Surveyor and later the Sojourner rover, part of the Mars Pathfinder mission, that research got a fresh boost. The Global Surveyor mapped the planet for over 10 years, discovering evidence of ancient lava flows and traces of flowing water. Meanwhile, Sojourner provided 16,000 images along with measurements of wind, pressure, and temperature. Another spectacular advance for those dreaming of understanding this enigmatic world. Sojourner was the first motorized vehicle to roll on another planet, setting the stage for all the robots that would follow on Mars. Although it was designed to last only 1 week, It managed to remain operational for 85 days. During that time, it sent over 2.3 billion data points and 17,000 images, helping scientists better understand the Martian surface's geology. In 2001, NASA launched Mars Odyssey, which made valuable discoveries. It detected an immense amount of underground ice in Mars's polar regions and recorded high radiation levels, a warning for future crews. Incredibly, the probe is still active, making it the longest-running mission on Mars, with enough fuel to keep its orbit for some time this year. We also cannot forget the twin rovers Spirit and Opportunity, stars of one of the most successful programs in the history of space exploration. Spirit operated for 6 years, while Opportunity exceeded all expectations by lasting 15 years. Together, they sent over 200,000 images and provided evidence that Mars, in a distant past, likely had liquid water, milder temperatures, and a denser atmosphere, all suggesting it may once have been a habitable environment. Moving forward in time, we reach 2005 when NASA launched the Mars Reconnaissance Orbiter, MRO. Among many discoveries, the MRO helped estimate the volume of water in the polar ice caps, calculated to be about 821 cubic kilometers, roughly 30% of all the Antarctic ice. Soon after, the Phoenix mission, launched in 2007, successfully landed in Mars's polar region, becoming the first to do so. The probe confirmed the presence of ice previously detected by Odyssey and even observed snowfall in the Martian atmosphere. It also found perchlorate, a chemical used on Earth as a nutrient for certain microorganisms. In 2018, the InSight lander added another chapter to Mars exploration. Without wheels to traverse the surface like rovers, it focused on seismological, geophysical, meteorological, and magnetic measurements, analyzing hundreds of Marsquakes. This data collection allowed scientists to gain a much better understanding of the planet's internal structure and tectonic activity. Jumping to the present, there's NASA's Mars 2020 mission, launched on July 30th, 2020, which brought the Perseverance rover and the Ingenuity mini-drone to Mars. Perseverance landed in Jezero Crater on February 18, 2021, at a total cost of $2.7 billion. This rover is expected to explore the area for several years, searching for evidence of ancient microbial life, studying rocks, and investigating the planet's geology and climate. It was also responsible for deploying Ingenuity, which exceeded expectations by flying dozens of times on the Red Planet. All these 6 decades of Mars exploration have revealed a world that is both grand and enigmatic, filled with wind-shaped dunes and deep valleys carved by ancient natural forces. Although we haven't yet found signs of microorganisms, we've discovered that Mars was once much more like Earth than we could have imagined. Every finding transforms our view of the universe and reaffirms that this is just the beginning of a journey of discovery. The future on Mars is promising. There are plans to send humans to the Red Planet in the 2030s, which represents an unprecedented challenge. If successful, this achievement could drastically expand our ability to explore space and generate scientific and technological advancements of unimaginable proportions. NASA is already working on life support systems, Martian habitats, and technologies to make such a long and risky journey possible. It's no exaggeration to say that living on Mars, though difficult, has moved from mere fiction to a real prospect, drawing closer with every new step. Space exploration is moving at an accelerated pace, and the possibility of a future on Mars is, above all, deeply inspiring. Our solar system has evolved from an initial chaos to a surprisingly organized collection of planets and moons. It's true that we always run the risk of a comet colliding with Earth at any moment, but jokes aside, the Sun will probably be the only star we can visit up close for a long time, unless we discover technologies like warp drives or shortcuts through wormholes. That's the subject we discussed in the previous video, which is appearing on your screen right now. For now, everything indicates that our source of light and heat, the Sun, will continue to be the heart of this small cosmic home we share. And thanks to centuries of curiosity and decades of bold missions, we are ever better understanding the past, present, and future possibilities of the solar system. So all that remains is to keep exploring, researching, and dreaming. After all, there is still so much to uncover. If you enjoyed this content, give it a like, subscribe, and share. Thank you for watching and see you in the next video.